So far we have been speaking about technology, we have been speaking about execution processes. So all this is from a technologist's point of view. We are thinking like engineers, we are thinking like the technology team who's creating the product, right? But there are many such pairs of categories in the world, right, of people who don't understand the other side's perspective. For example, there are Harry Potter fans and there are Lord of the Rings fans. They never understand each other. There are Apple users and Microsoft users. They will also never understand each other. Similarly, at times I feel that there are technologists and consumers of technology that often struggle to understand each other's point of view. The problem is that both these sets cannot exist without the other, right? So it's necessary at times for us to get into the mind of the consumer, right? And to be honest, many times we are ourselves in the role of a consumer of technology, even if we don't realize it, right? So a very apt cartoon I usually use whenever I talk about consumers is what I put up on the screen. That engineers are always trying to produce better things, right? Make life easier for other people that are the consumers. And the consumers, this is engineers' perspective that why don't they see what how much easier it will make life for them. But obviously there's always a second point of view, right? So for the next 90 minutes, if I can request everybody that let's park our technologist brain for a minute and put on the hat of a consumer, right, and see what's going on there. So this session is about looking at IoT specifically, any technology, but more specifically, we'll be talking about IoT from a consumer's point of view, right? Um, why this, if I have to describe this session in just one line in a nutshell, this is the slide I would use. This session is about, as consumers of technology, we need to be empowered. So for this session, we are all consumers of technology. So as consumers, we need to be empowered to take informed decisions. We need to understand technology to a little bit. We need to understand how we can use technology, and we need to do it so that we get the optimal solution at the optimal cost. That's what we want as consumers. As consumers, we are not too much worried about how the technology works, how much effort has gone into it, what is the next great thing, new upgrade that's going to be. We want to be empowered to know what is the right decision to take and to get the right product at the right cost. Okay, from tech providers. So that's why in this session we have been tech providers for the last 6 sessions. So we'll not talk about tech providers side at all this time, right? As consumers, we have certain goals. We want to produce better results for our organizations. We want to do things faster, cheaper, of higher quality. And how do we use the presence of tech providers, and specifically when we are dealing with Internet of Things providers, into meeting our goals? Okay. And if we can understand these bits, it helps us in a lot of ways. First and foremost, being informed. I think the keyword for this entire session should be being informed consumers. If we are informed consumers, right, we can elicit better products, better services from the people who are creating the technology. We can ask for the right things. All right. Second thing is there will be many providers in the market, right? They will try to sell us things that don't really solve our problems. That will sell us things, for example, when we buy a mobile phone, we end up using only 40% of its functionality. 60% we have paid, but we don't use. And that we'll come across many such products and providers also, right? That is not ideal for our needs, okay? Unless we tell people that these are my constraints, these are my needs, give me a solution that works for me, not works for you, right? We will not get the optimal solution from a provider. And the third part I think is very important. I think in many ways this is cultural, that we are not very comfortable talking about money. Okay, we take a long time to get to talk about the money aspects of anything, but that is in many ways the most important aspects, right? As the buyer wants technology's cost, because when a technology consumer and provider are meeting and talking about a deal, if both of them, if the That the bill
Abhijit,
is not going to
Abhijit,
happen.
there is a problem with your audio. It seems it is breaking.
Uh, Let me check. Is it a problem with everybody? Anybody else can hear me properly?
Yes,
No,
sir. Yes.
there is no problem.
Yes, sir.
I think, I think local network might be having a problem, Dr. Patel sir, then.
All right, continue.
Yeah, yeah. Thank you. I'm going to, there's some background noise. I am going to put everybody on mute, but feel free to unmute among the organizers. Right. So what happens is, and we come across this a couple of times every month, that as consumers we are not aware of the monetary value of the technology, and as a result we enter into negotiations thinking something is going to cost 10,000 and actual cost is going to be 5 lakhs. So there is no meeting point, and as a result both parties suffer. The consumers also suffer and the technologists also suffer. So it's very important we as technologists or we as consumers must be aware of at least the ballpark costs of these technologies. All right. So let's take a look at these with these three goals in mind. Let's take a look at what's going on in the consumer's mind. All right. Right. Ultimately what we want is a win-win for both the consumer and the technologist. So I'm going to go back to a couple of slides we have taken on the technology side, because before we become consumers, when we become consumers, we must have a good idea of exactly what is being sold to us. Okay. So as a refresher, what does the technology provider do for us? Look at the same slide now, but from the eyes of a consumer. The provider is going to build a foundation layer for an IoT solution, which means there's going to be some connectivity, things talking to other things. There is going to be some power requirements that as consumers we need to make sure that whatever somebody sells to us, that device should get wall power or battery power or solar power. And thirdly, what kind of processing we want them to do for us. All right. Now, you might think this is an entirely technology decision. It is not, because there are constraints involved. Now, if I am a consumer who wants an IoT device on my farm, then I need to make it very explicitly known that boss, I'm not going to give you Wi-Fi. I'm not going to give you internet. You need to come up with a solution that does not need internet. Now, I don't need to know what that solution is. I don't need to know there is LoRa and there is radio and there is SMS. What I need to say is I don't have internet. Figure out another way. Okay. Similarly, power, you can say I'm on a farm. I can't give you 220-volt AC. Figure something else out. Okay. And processing thing is a little more complicated. Most consumers are not aware of processing, but I will still give you some examples where because of good decisions or poor decisions of consumers, a product is successful or not successful. All right. So even when the providers, the technologists are building this layer of the product for us, there has to be some form of input from us from a consumer point of view in the form of what are our constraints, right? After that, you will remember we spoke about the pillars of IoT. There's an edge layer, there's a protocol layer, there's a cloud layer, and there are tools. All right. Now, this is one part of the solution where consumers don't need to have any input. This can be black box. We don't even need to know there are four different kinds of things happening here. So we can entirely leave it in the hands of the professionals building the solution. And then when you say what is the functionality we are getting, now this is again some area where we as consumers are defining what happens here. We as consumers define what we want to monitor, what we want to control, what are the numbers. So thresholds become very important. For example, if you are building a water conservation system, I need to know whether I need my tank 90% full at all times, 75% full at all times, or 100% full at all times, right? And whether I want my tank to fall below 20% or 10% or 5%. So those thresholds, those monitoring data is all to be defined by us as a consumer. Somebody else will build it for us, but the functionality has to be defined by us. What data are we looking for? So we spoke about a smart helmet solution. It was yesterday. And see, the technologists will build the helmet, but we as consumers are going to look at the heat map and we will say I want it as a heat map so that I can immediately spot the red areas on the map and then build flyovers there or traffic lights there or one way streets there. Okay. So whatever happens in this top layer is entirely driven by us as consumers. All right. So once again, the foundation layer, consumers input is constraints, what works and what doesn't work from a functionality, from a technology perspective. The next layer, um, consumers, we don't need to worry about it. The next layer, we do need to worry about it. Okay. Think of it this way. Think of it as you've gone to an architect to design a house for you. You don't really care about this part as well as the foundation is strong. As long as the foundation is strong, you don't care about what kind of civil engineering is going into the pillars, the columns of your house. But this is the place where you say this is the layout I like. I want two bedrooms and one balcony and two bathrooms and a terrace, and I want a porch light and everything. So this is entirely being defined by us. Okay, that is the functionality. Okay, and why this is important is just like when you go to an architect, the architect will build the house for you, right, and go away, but we have to live in the house forever. So it is good for our benefit that we take a stake, we take an interest in how the whole thing is being built for us. Okay, most technology products, most IoT products are still custom made, so we have to take an interest in what somebody is building for us. All right. Then we went into this aspect, different kinds of evaluation. Once again, evaluation is not the headache of the consumer. Constraints are, right? Now, let's not worry about connectivity and power, but so many times on the processing front, our clients are savvy enough to tell us, boss, I don't want you cutting my wires, figure out some other way. So that's when we said, I know, we generally offer these kinds of solutions, non-intrusive solutions. So this is on request by our clients. And if our clients were not informed enough, they would never be able to tell us their problems. Okay. Very recently, we did some consulting for government of Bihar. We'll see that project also in this presentation. And they, on the first day, they told us, boss, our solutions are going to be in rural parts of Bihar. There will be 4 hours or 6 hours of electricity in a day, or maybe 8 hours of electricity. You must provide some solution where it will still continue to work when there is no electricity. They might not know about different kinds of batteries or solar arrangements, but they do know enough to tell us that, boss, don't rely on 24/7 electricity. We cannot give that to you. That is a sign of an informed consumer. All right. So this is the kind of thing that informed consumers tell us. Other thing about processing is, especially when you talk to industrial consumers, they are fairly well informed about different processing networks because they keep reading trade journals and all, right? So when we talk about IoT, there are basically three kinds of processing you can offer to people. A very large scale plant, you can offer things like PLCs, programmable logic controllers, or FPGAs, all right? Or you can offer them slightly lower value, lower complexity devices like a Raspberry Pi for their processing. Or you can go to the much smaller, the things that we have been talking about throughout the practical sessions. You can give them the smaller microcontrollers in small boxes. This is the box I've been showing you all through this workshop, right? And let it do the work. Now, where the difference comes is how big of an operation you have. Okay, and there'll be many players in the market where you'll say, oh, you want to control one machine, I'll attach a PLC for you. And for something that can be done in 10 to 12,000, they will charge you 60, 70,000 rupees. All right. So as consumers, we must be aware that what are the different options. So we can ask questions. Hey, why are you offering me PLCs? Why don't you give me something cheaper? All right. So that's the power. And I will give you some very strong examples where people do this and also where people do the wrong thing. Okay. So let's move forward in the session and these examples will come up. Okay. So that's the role the consumer has to play here. All right. Now, similarly, when we talk about the functionality layer, one of the most time we spend with our clients, because the client is only going to be worrying about data, right? They don't worry too much about the sensors or the processing and all, but they do worry about what data we are showing to them. And the most amount of input we get from a client, and rightly so, is this is what my input should be like. I want to see comparative charts of my machines. I want to see how much production my 20 machines have done in the last 6 months. I want to know which of my employees has been most productive. So this is the kind of input customers give us. All right. So which is where we as consumers need to define what kind of data we are going to get at the end, right? And once again, just a quick refresher before we do a deep dive into the consumer end. These are the four layers of IoT. Okay, now I'll show you a slightly different representation. I'll not show you, the chips and Raspberry Pi and all. I will show you how these look to the consumer. Okay, the consumer thinks this way. There will be some sensors. They don't worry about PCBs or node MCUs or Wi-Fi or whatever. There are some sensors that are sensing the stuff in their shop. Maybe it's production count, maybe it's a fire detector, maybe it's how much electricity is being consumed. It's some sort of sensor that is measuring something. All right. And there are actuators that are changing something. So very recently we had a client who told us, I don't want you to measure the electricity, but what I want you to do is I'm giving my meeting room to people for 1 hour durations. So they come to the portal. We are also building the portal for them. I want to allow customers to book a room for meeting. All right. So I want to allow them to select time. I'm going to have my team meeting from 10 a.m. to 12 noon, and after 12 room, I will give back your room. So they have told us that after that period is over, just disconnect electricity from meeting room by default until the customer pays again for more time. And all this done through IoT without human intervention. So that's what we mean by actuators. What kind of control elements you want to build? Okay, so this is the edge tier. This is where okay, so before I tell you what role the consumer plays, let's go forward. Gateway tier, again, maybe router is not the right choice every time. Basically internet and SMS, these two are the most widely used means because they are inexpensive, they are easily available, and they are very effective. Some cases we have to do, just like yesterday, Chamundeshwari ma'am requested that do we have a adapter for LoRaWAN. So some cases customer might not know LoRaWAN, but they are going to tell me, hey, my installation is in the desert out there 50 kilometers away. So how do I reach it? There is no SMS there. So this is the kind of words and phrases they will use. They will not tell you LoRaWAN. But as technologists, the technology team will have to figure out that, yeah, they are saying it's 50 kilometers away. There is no cellular network, so it's a constraint. What is the answer? Answer is LoRaWAN. So that kind of constraint to technology mapping is the job of technologists, and articulating the constraint is the job of the consumer. All right. So these are the kind of constraints that will arise in a gateway tier. One of our very first industrial consumers, we thought we'll have a difficult time talking to them about technology, but first off the bat, in the very first hour, they said, boss, I like this idea. I like the idea of, storing all my stuff on the internet, but my fiber optic cable, gets disrupted about once a week. And the customers are savvy enough to know that if my fiber optic cable is down for 1 hour, for one entire hour, no data will be captured by the internet. And just like in yesterday's session with Purva, data is very unique. Software you can restore and reinstall, hardware you can repair, but data once lost can never be recreated. It's like time. All right. So, and the customers are savvy enough to know this. So that's why they says, give us some solution by which we will not lose data, even if there is no fiber optic cable. In those kind of instances, what we do is, let me come to get my magic box here. So I have a magic box of stuff to show you for different kind of things. So in those kinds of scenarios, we are offering a Raspberry Pi as a local server. So the local server sits inside the shop, does all the local data capture. Whenever there is internet, we transmit it to the cloud. When there is no internet, we keep all the data secure on the Raspberry Pi. I think I've looked at the feedback from day one yesterday. Thank you. It's a very motivating, rewarding feedback for us. One of the requests is, can we also talk about the Raspberry Pi a bit? We'll definitely find an opportunity before we end to at least give you a taste of the Raspberry Pi as well. All right. So these are the kind of constraints that arise in the gateway layer, right? On the data processing layer, once again, this is largely hardcore technology. Consumers don't really worry. As consumers, we should never try and define how this technology should work. Okay, so no input we expect from consumers in this one. But on the user tier, yeah, so this is what is happening. What kind of data is being exchanged? What kind of commands are going back, etc., etc. What kind of data is being stored? On the user tier is entirely defined, as I said, by the consumers, because they are the people, they are the kings who tell us this is the value that I'm going to get out of the system. All the cost that the consumer will pay is being paid because of the user tier, what they get out of the system, not for what the sensors and actuators are doing. All right. So let's take a look at, what role as we as consumers should play in each of these tiers. In this tier, we are going to ask for alternatives that, okay, you are giving me a sensor that can talk. What is the range of this sensor? We want to be informed consumers. So somebody says, take this radio sensor and it will cost you 5,000 rupees. And then the question should be, oh, 5,000 rupees. What is the range of this sensor? And then I will tell you that, this can talk over 5 kilometers. Why 5 kilometers? My buildings are within 1 kilometer. I don't want this sensor. Okay, give me something that can talk to over 1 kilometer. So that's the kind of informed choices we should be making. All right. Alternatively, somebody might say, hey, I'm going to give you a Wi-Fi device. And as a consumer, we should say, I don't have Wi-Fi, boss. My devices, my buildings are 2 kilometers apart and there's no Wi-Fi that can work. So give me something that can work at a longer range. So the edge tier is where we articulate our constraints and we ask for options. All right. Similarly, in the gateway tier, we tell them our concerns. What if my data gets lost? How do you secure my data? I might be doing some sensitive operations. I don't want my competitors to know. I'm a consumer now. I'm not an engineer right now. And I will ask the engineers, how will you secure my data so that my competitors cannot look into it, right? On the rules engine and the data processing side, no input. And on the user tier side, we will define what happens. This is entirely our area. We get to decide and define what happens in the user tier. All right. Um, why we are talking all this? When we are talking, we are consumers. Why should we know all of this? I will tell you why. Because see, the gap in knowledge between people who are pure consumers and pure technologists is reducing, and this is very obvious. Let's take a common example. If you go to a shop to buy a laptop, now even somebody who is not a computer engineer or any kind of engineer knows enough about what questions to ask. We ask the salesperson, how much RAM does this machine have? We might not even know what is RAM or what does it stand for. But we know that 8 GB RAM is better than 4 GB RAM. We don't know what is GB although. But we know to ask this question. Why is 8 GB RAM? Why are you not offering me a 8 GB RAM option? All right. We know processor speed matters. We know that these days you need terabyte hard disk, not 50 GB hard disk. So even not being informed about the technology, we are informed consumers. Okay, when we go and buy a vehicle, we ask questions about mileage, we ask questions about speed, we ask questions about emissions. And these days we also ask questions about what all sensors the car has. These are all informed consumer decision questions, right? So it's very important. If you don't do this, I will tell you what happens. We are very savvy when we buy computers and cars, but we are not savvy enough when we buy technologies like IoT or artificial intelligence, etc. And I'll show you what happens when this gap exists. And we see this gap every month. This is what, as consumers, we think we want this. All right. We think we should pay for this. All right, we want this, but we are willing to pay. We have budgeted for this. Okay. When we explain it to the engineers, this is what they understand and build for us. All right. But what we really wanted, what we really needed in the beginning was this. Okay. But because between the consumers and the providers, we cannot articulate our choices, and it's the responsibility of providers too to ask the right questions. Okay. So when we go, as my company, we go to a client site, we take a checklist and ask questions. Does your site, do you have sites that don't have Wi-Fi? Do you have reasons to talk to your SMS? Do you have, oil spills and electromagnetic interference? Do you have concerns about, your fiber optic cables, etc.? So out of experience, we have developed this checklist, but not all providers are going to have that kind of thing. Okay, so they are going to misunderstand the requirements, and ultimately what you wanted wouldn't be built, and it will not be useful to anybody. So remember this chart. This is why it is required for consumers also, us as consumers, to understand technology to a limited extent, right? Um, I'll give you some examples of use cases where these are live consumers coming towards us or people that we know. I'm not picking these examples from textbooks. I'm picking these examples from real life requests that we have received or we are familiar with in reality. what kind of requests people are making. Okay, there are many use cases, but these are the largest segments of use cases that people are requesting IoT for. All right. The largest consumer bracket falls under industrial IoT, and worldwide industrial IoT means a lot of things. It also means going towards industry 4.0, very nice and fancy things. But in the largely Indian context, these are MSMEs who have very point specific problems. For example, they have machines which are 30 years old and they want to compete with Taiwanese machines and Vietnamese machines, which are all automated, all CNC machines. The problem is these machines are working fine. You don't want to throw them away just because they are not computerized. So they request us, can you make our machines smart? Okay, we don't want to buy smart machines. We have machines that are working perfectly fine. There's nothing wrong with them. But today I have a supervisor who does the round of the floor making note of everything. Is the machine broken down? How much production this machine has done? What is the attendance of my staff today, etc., etc. I don't want human intervention. I want all of it automated. These are the kind of use cases that come to us. Okay, so this is a very common example of the largest percentage of use cases for IoT. You have a shop floor, you have certain machines in the shop floor. These are traditional machines. Okay, now what consumers need us to do is deploy smart devices on them, and from this point onwards they become smart machines. Okay, they can think, they can act, they can talk to the other machines on the shop floor, they can send all that data to the local master, which, as I said, in our case many times happens to be a Raspberry Pi. It could be a PLC, it could be an FPGA, or it could be a Raspberry Pi for simple use cases. Okay. Then what happens is all that data is goes and sits in the cloud, and from the cloud it's all the kind of magic you can do. You can bring it to their mobile phones, you can integrate it with their database system, you can give them very nice charts and dashboards. All the stuff we have seen in the last 3 days you can do for them once the data is on the cloud. The customer sees what is happening on the shop floor and what is happening on their mobile phones as a result of all that data. All right, so this is the first kind of use case we get. If we zoom in into this use case a little bit, what all different kinds of things are there? This is, I have picked the most popular, the most prevalent machine. This is called a power press. This is used very extensively in manufacturing industries. So there are different kinds of jobs that that machine does. It creates bolts, nuts, it creates sheet metal objects, it creates all kinds of things. Okay, so people want us to monitor in terms of numbers production, in terms of weight production. So all those sensors are attached at different points of this machine. I'm showing this to you from a proper design document from our own installation. Okay, how do you do it? At different points of the machine, just like we said yesterday, we are going to put, although this device is too big because it's a development board, we put the smaller version of our devices at different parts of this machine. It does counting, it does weighing, it does monitoring, etc., etc. Is okay. Oh, I think this background noise. No worries. So this is one kind of tracking that the devices do. The other kind of tracking is a very common use case is track delays. How much time did the power outage last? How many times did I run out of raw material? How many times and for how long did my machines break down? All right. All that goes into something called a performance report. All right. How long did my tool last? They're cutting tools, they're grinding tools, they run out of life after a few thousand pieces. And all this is called OEE, operational efficiency. Okay. And similar stuff. So each machine is going to have a device like a Raspberry, not a Raspberry Pi, but a small device that we shown. All the data gets translated to the cloud, and what the consumer gets in the end is a very nice dashboard in one place. Maybe it represents 3 or 4 or 5 factories all at once, but this is the most common use case we get. All right. Um, Other kinds of use cases is, machine performance report. Every machine is doing something. All of that goes into a paper report and is slotted into a file at the end of the day. Nobody reads that report. Okay. Now what people want is, I don't want that paper report at all. I want all of it ready made with analysis done. So I'll just come at the end of a day, I'll look at daily report. I'll come at end of month, I want a monthly report. I'll come at the end of a quarter and I want report for all 3 months. etc., etc. So they want all the kind of reports from all the data that has been generated here. Okay, these are things that are called machine performance reports. Um, Another kind of use case in industrial context we get is, so far I've shown you machines from an industry 2.0 era, right? Where these are electrical machines, all right, but they have no automation built in. Contrary to that, a lot of industries have already moved on to what are called CNC machines. So I've just put up the picture of a CNC machine in front of you. Now these don't need for us to put up, sensors and all. So if I'm a consumer who owns a factory with CNC machines and an IoT provider comes and says, hey, I'm going to put all these sensors on your machines. I should say, hey, I have a CNC machine. I have all the sensors already. I don't want sensors anymore. But all that data is coming from the sensors and already being displayed on my screen. How do I grab this data and take it to my database? Don't sell me sensors, sell me something else. So that is why, what consumers need is some kind of a visual arrangement. Normally what we do is we put cameras in front of their digital displays. We don't put a single other sensor. The camera reads their screen using computer vision, transmits all that data, converts the image to a text, transmits all that data to the cloud, and then it goes and sits just like any other sensor data in the same dashboard. Ultimately, no matter what kind of machine you have, the customer is going to pay for what we show on the dashboard. The customer, all right. Well, if it's a non-smart machine, we put sensors. If it's already a smart machine, it's just not talking to anybody, right? We put cameras and all in front of its existing display, read it and transmit it somewhere else. Okay, this is the second kind of use case we get. Third kind of use case is security or safety related, not just for industrial safety. Exactly same kind of use cases are emerging for e-vehicles or autonomous vehicles or drones, because now governments have allowed drone-based delivery. You don't want drones colliding with other things. Okay, so you need to gauge how far away other objects or other obstacles are and change trajectory accordingly. So these are the three industrial use case which make up the largest slice in the pie chart. All right. Apart from these, there are we looked at this dashboard yesterday again. Apart from this, you need to do what kind of evaluation you need to do as a consumer. Okay, what kind of questions I need to ask. Okay, so for internal to the shop, to the factory, or to the office, what kind of communication are we gonna do? Whether I have Wi-Fi, whether I have wireless, whether it's going to be a wired communication, whether it's Bluetooth. So I need to ask some of these questions. Okay. Secondly, what kind of sensing arrangements I want? I don't want the producer cutting my wires. What all you can do through hardware versus software? It's a big question, because the more that can be, the longer lasting it is, the less it will cost, the less maintenance it will need. Okay, and we have had many cases where initially we thought that the problem should be solved through hardware, but because of the cost we moved that fix into the software. There, because there's a cost, right? Hardware works much faster, people can see it, so people know what's happening. Okay, so we need to make sure that our providers are fixing the right problem in the right layer. All right. Thirdly, what kind of computing power we are going to use? Do we need something big like a PLC, or a small microcontroller is open to us? All right. So you would think that this should not be a decision left to the consumer, but I'm going to give you, towards the end of this presentation, I have a case study. I will show you where consumers are making wrong decisions sometimes, and later on that's not working in their benefit. Okay. And thirdly, what are the environmental challenges? Do I have a shop floor with a lot of metal and which causes electromagnetic induction? Do I work in a place which has poor lighting conditions? Do I have availability of internet? Yesterday I showed you some boxes, right? That there are intrusion protection boxes. So do I need intrusion protection? So if the provider is not thinking of these things, as I said, the house somebody else will build, but we have to live in it forever. If the provider doesn't ask these questions, we have to articulate that how are you catering for the moisture, or how are you catering for the oil spills that are happening on this machine, etc., etc. Okay, informed decisions, informed consumers. The next use case is to do with governance. So in the past 2 years, we have provided consulting on two different government projects. First of them was a water reservoir management system for government of Maharashtra, and second is very recently government of Bihar has introduced, Har Ghar Jal Yojana, where they are trying to get tap water to every single house in the state, and that will be expanded to the rest of the country as well. So I'll give the example of this one. And the biggest problem with these kinds of, as a consumer, if I'm a consumer of this system, the largest problem that I'm going to have is scale, because I'm not going to have all my requirements all at once. I know the first few requirements I have, but this project is going to grow pretty large pretty soon. Requirements will keep coming, programs will keep changing, new, and my customer base is going to be very large. I'm talking about millions of customers here. So as a consumer, I should think of scale and I should think of phased manner. Now we have had a few consumers who absolutely did not think of it at all, right? And that's why the project didn't even get off the ground. Okay. And there's a lot of difference between when we are saying I want a software solution versus when I say I want a hardware or an embedded solution, because embedded solution can't be tweaked every time. The hardware is built, the prototype is there, the boards are there. Every time you want to make changes to the solution, it costs much more than if you just want to change the software. There's cost of design of the hardware, there's cost of production of the hardware, and if you are going to deploy it in 10 places, you need 10 units of the device, unlike software that you deploy it only once and use it from 100 mobile phones. Okay, so as a consumer, I need to be aware that there's a difference between using something which is tangible, which is hardware, and using a software service. Okay, so the most important question, so in this case we had a very limited requirements to begin with, that there's a water tank in every village and there's a big motor that is raising water to the tank. So first control element as a consumer is I want the motor to switch on and switch off at a periodic interval of time. Every day 4 o'clock in the morning and 6 o'clock in the evening the motor should turn on, run for an hour and then shut down. That's the control element. Okay, and on the other end, when consumers are consuming water from the tank, I want it to be controlled by a solenoid valve. I have one right here. This is a small scale valve. This is good for gardening and all. This cannot be used for supplying water to a village. Those are much bigger valves, but this is in principle, this is the device we are talking about. If you look at my camera feed. All right. So this is the other. So the requirement started with just these two things. Okay, that I want to control pumps and I want to control water outlets which goes to the villages. And very soon a lot of elements came up. We want water purifier, we want backwash controller, we want to measure how many liters of water has been consumed. And this is another challenge as consumers we should be aware of, that your requirements are not going to remain the same, right? If you have an entirely software solution, you have much more flexibility as consumers. But if you're going to do a hardware embedded and IoT solution, we need to have in mind that let's phase it out. Okay, what kind of phases? What do you want first? I want the motor and the solenoid first. What do you want next? I want to measure the quantity of water being used, etc., etc., etc. As consumers, in our minds, we need to have those phases in already planned. Okay, so what kind of evaluation that the consumers need to think of? Do I again have connectivity or not? What kind of power? For example, this consumer was very savvy that we are not going to have power 24/7. We'll only have power for 6 to 8 hours a day. So we need to articulate that as consumers. Okay. What kind of sensing we need? Do we need to release only water, or do we also need to measure how much water we are consuming, etc., etc. And once again, environmental challenges. Okay. So this is another use case that is becoming very popular. And on a side note, friends, normally we attach in our minds, we think of governments as being the last people to adopt technology. Surprisingly, in both these experiences, the requirements documents we have got from the government departments is better than any other requirement document I have seen for the 16 years I was working in proper IT. So of course they are not producing it themselves, they subcontract it to Accenture or to KPMG or to other players, but they're doing a really good job in terms of articulating the requirements. They're very crystal clear. It doesn't leave any doubt in our minds. All right. So something to feel good about. Our tax money is being used well in that case. Um, the third kind of use case as consumers that we often have is smart spaces. These may be smart living spaces, these may be smart office spaces, these may be smart societies. All right. So one example, a very small example, just one use cases, as I said, two use cases, two requirements somebody has, that I have this building, each floor I have given off to somebody else to use. I'm going to bill them by how much power they consume and how many computers they have and how long they use the meeting room for. If they're not paying for the meeting room, I'll switch it off all through the IoT systems. Okay, so there are two requirements here. One is a control element, switch on and switch off power to the building, and secondly, monitor how much power is being consumed at an every 10-minute interval. Okay, and of course, the other things are coming. If you are using more power you have paid for, you'll get an SMS. We'll give you a portal to pay and all. But the IoT part is these two things. And I am surprised how many similar requirements we are getting. We keep hearing from people, can you build something similar for us, etc., etc. So really good use case as a consumer mind. All right. Um, there are many other use cases. I'll just quickly list them. First is energy conservation project, energy and water both. All right. Uh, for example, we are thinking of smart cities. We are talking about smart street lights. All right, where we say that if I don't want a timer. As soon as it is evening, I want the lights to go on. As soon as it's morning, I want the lights to go off. And the time it will happen is different in the morning and evening both. Okay, so smart lighting conservation. We have seen a lot of societies, society managements think about water conservation. All right, and sometimes we get some very interesting use cases. So last year there was a requirement that there's a very big society in Pune that had four different buildings, and all the four tanks were being serviced by the same big water pump. And what happens over time, the pipes start corroding, etc., and one tank fills up very fast and all the other tanks fill up slow. As soon as the first tank fills up, it starts overflowing and they have to shut off the motor. And the traditional approach would be you separate the motor and you put four different motors. Is a very expensive deal because you have to redo the entire piping and all. So we suggested an entirely IoT based approach where each tank will have its own solenoid valve, and the tank will inform the solenoid valve I am full, stop, and the motor will only stop when all the four tanks are full. So that way we make sure that all tanks are slowly filling up in pace with each other. So water conservation projects. So these kinds of home automation, office automation, hospitals and hotels, because patients and guests know when they want to switch on their water geysers and heaters and all, and they don't switch them off. So they want a timed based something like that. So these are also very common. The second kind of things we have, I have already told you about that, government projects, water conservation, water distribution control systems, right? And the third one, which I'm very happy to share, is coming up, is smart agricultural systems. Now, of course, this is the smallest slice in our pie chart, but it is coming up quite fast. Every 6 months or so, we hear more and more cases where people want smart irrigation systems, etc., etc. It's not just water control; it's pesticide control, it's lighting control. If you have vegetable farms working in greenhouses, you can also do lighting control systems using IoT. Now people have started doing something called hydroponics, where it's like farming without soil. So except for the substrate, which is coconut powder, all other things you provide from the water pipe, nutrients and pesticide, lighting you control, humidity you control, everything you control. So almost a perfect project for IoT. So we helped in a similar project in a college in Amravati last year. So they are trying to build up a greenhouse and grow strawberries in Amravati climate, and it's an entirely IoT driven project. So these kinds of things also consumers are doing now. All right. There are many more use cases, but I thought I will show you the things that come up very often, in our radar. And no matter what, as I said, this slide we have seen before, people are not going to, as consumers, we will never know. There's something called GPRS, there's something called GSM, there's something called HTTP or whatever. Wi-Fi people know because we use it every day. But as consumers, people do know what they have. So people do know that, I am working in some place. Just give me a moment. Just give me a moment. I'm sorry for the interruption. So people do know what they have. So either I have Wi-Fi or I have SMS reach or I don't even have SMS reach. Okay. So as consumers, we must know all these constraints, and importantly, we should articulate it when the solution is being designed. Okay. So let's be familiar with this picture. It's a very, for me, this is one of the most important visual for this entire program. So all this so far has been about functionality, and as we said, we don't talk often enough about the money aspects. So I'm going to talk about the money aspects for the next 10 minutes. Let me find. I have a very good visual for you there. Just one moment. I'm just bringing up a very nice visual for everybody. Right. So while it loads, let me go back to our slide. So let's talk about, before we talk about money, as in how much an IoT system costs to a consumer, let's talk about the different ways that the pricing happens. All right. So there are many different ways, and this being a very new kind of technology, people are really, confused as to, how should I charge and how should I pay. But over the last few years, these six major pricing models have emerged. Okay, and I'm sure that you will not see this in almost any other program, because we also had to struggle to find all this stuff, and this is a struggle we have every week, that should we go with this model or that model. So I thought it's a really good slide to add to this consumer orientation session. Okay, so I'll walk you through very quickly with each of these six different ways IoT systems are priced. The first one is the most obvious. It's called an outright sale. For example, if you come to me that I want to, as a consumer, I want to build a smart campus. I want to build a smart streetlight solution in my campus, and every time my principal drives in, I want to get an SMS that your principal is now in the campus, for example. Okay, so you can simply buy all the hardware and software from the provider. It's an outright sale. It's a one-time sale. You pay the amount and it's yours forever. All right. Of course, there'll be maintenance and all will happen, but you are paying for that product only once, and then it belongs to you. All right. Most simple, most easy to understand. The next model that is emerging is called subscription based. And I think in the last 5 minutes, I will tell you a case study where we have done both outright sale as well as subscription based. Okay. So subscription based is a little different. What it means is I'm a consumer, and let's take the same example. You are a consumer, you want to build a smart campus, but you don't want to pay me 5 lakhs or 10 lakhs at once. Or what you will say is, I just want to pay you accordingly how much I'm using your system. Just like we spoke about, cloud and all. So what we will say is, okay, you got 100 street lights, pay me per device per month a certain amount. So you are subscribing to the service. In the first month, you just have 5 street lights, you pay for 5 street lights. Over 6 months, you have all 100 street lights operational, then you start paying me for 100. So it is a subscription based pricing. Some amount, X amount per device per month kind of thing. All right. The next is a very interesting model. It's called outcome based prices. This is not per device. This is not an outright sale. Let's say you're hiring a technologist to automate your water distribution system, right? So outcome based pricing says I will charge you for every liter of water you pump, or for every 100 liters of water you pump. So it doesn't matter how many devices, whether I use 5 devices or 20 devices. Don't worry about that. That's an execution detail. What is the outcome you are getting? What is the functionality you're consuming? Is how much water has been controlled by that system, and pay me by that. That's called outcome based pricing. All right. The fourth model is called revenue share. Right now, taking a step back, the first three models we have seen people will do when I'm not going to when the consumer, I'm not as a consumer going to earn money from this technology. I'm saving cost, I'm increasing my efficiency, I'm building a better product, but I'm not earning money. All right. Contrary to that, let's say Ola or Uber or Redbus or somebody else uses our technology to earn money. They are earning revenue from their customers based on our technology. In that case, what they can say is, I will take a share of your revenue. For every bit of business that you do using our technology, pay me 5% or pay me 2%. This is called sharing revenue. There is no outright cost. There is no money to be paid per device. There is a percentage of the revenue, whichever what that device has made for you. It's something like you can say royalty from books or from patents, right? Every time your product is used, you get a percentage, right? The next model is getting very popular. It's pay per use. It's like Ola and Uber, that every time I use a service, if I'm traveling 5 kilometers, I pay it, then I stop paying. All right. So it's a service based model, pay per use model. However many seconds you use the IoT system, you will pay for it. All right. And the last model is a little tricky, I would say. I will tell you what it is. It's called data monetization. Now, let's say you as a consumer own an agricultural farm and you have engaged me as a provider to automate irrigation on that farm. All right. Now, this model says that don't pay me anything. All right. I have got 100 consumers like you spread out all over Maharashtra or Karnataka or Tamil Nadu or Delhi or Himachal Pradesh. What I'm going to get is the data that the system produce will be mine. For example, how many crops do you have a year? How many liters does a wheat crop consume versus an apple orchard consumes? How much pesticides do you use? How much light falls on your farm? How much rainfall you get? How many times in a year, how many hours in a year does your motor run? All this data I will capture. I will make a data bank. I will anonymize it. I will not obviously use the consumer's name, but I will sell the data to the people. It's all ethical. I'm not selling anything on the black market. I have taken your permission to anonymize your data. That data belongs to me. Okay, this is what think tanks do. This is what banks do, which do consulting work. They have a lot of data, right? And data is their business. So they don't ask for money. They say, I will own the data, and I will use the data as I see fit. This is called data monetization. So when you say why is, in a way Facebook free, why is LinkedIn free, why is WhatsApp free? These systems generate a lot of revenue by selling, not our names, but the general sentiment. We spoke about sentiment analysis earlier. We'll look at it again. What is the sentiment about a new product? All this stuff is monetizing of the data. Okay. They may be used in isolation, they may be used together in combinations, etc., etc. But these are the six major ways that people have come up with to price IoT solution. Very different, so very interesting technology. That's why there are very interesting ways to make money from this technology also. All right. So these are the pricing models. Now let's talk about the actual how much does it cost, right? If I'm a consumer, what do I expect to pay for such a technology? And to be honest, this argument holds true for all the niche technologies. People are fairly informed now, what to pay for a website, what to pay for a mobile app, what to pay for somebody else. People generally know. People don't know what to pay for big data or for IoT or for artificial intelligence or augmented reality like systems. Very new systems, and people are still discovering use cases for these. Okay, so let me take the next 5 minutes to tell you generally how much these systems cost. Of course, there's a lot of gray area here, but use this as a guidelines that what all goes into it. Okay, so very largely there are four elements of cost to these systems, specifically IoT systems. The first one is the actual, development cost. If you ask a provider like me to build a smart campus, let's stick with this example. There will be some development costs. We will design and build such devices for you, and proof of concept it, we'll breadboard it, we will prototype it on a zero board, we will productionalize it on a PCB, we will test it in the field, we will put it in a nice waterproof box, etc., etc. All that is development cost. There are procurement costs also. Okay, for example, I am going to procure SMS gateways to send notifications. I'm going to procure maybe other services. So all this is procurement. So these are all the stuff that the technology agency is doing on your behalf as consumers. All right. And then there are software costs. So far we have seen all open source and free software, but there are paid license software also. Okay. So maybe the technologist is paying for that and that cost will be transferred to you as a consumer, right? All this is a one-time cost. Next comes extraneous hardware cost, which is not really part of the product, but just a while ago I showed you a solenoid valve when you want to control access to water to a tank, etc. There's a very small valve, but if you're looking at industrial valve grade valves, these things cost like 10, 12,000 rupees. This one is very cheap, but the production ones cost a lot. So they don't make it part of the IoT system. It's a separate hardware procurement. It's also a one-time expense. All right. The other two blocks, the bottom blocks are not one-time costs. These are recurring costs for the system. All right. For example, the first block is infrastructure costs, which means, and I'm very happy now, accidentally, that we have already covered infrastructure, right? We covered the MQTT gateway, we covered the rules engine, we covered the database, we covered webhook, etc., etc. All that is infrastructure, so somebody is paying for it. For example, if I intend to send like 100 notifications over SMS a day, each notification costs about 30 paisa or 40 paisa. Okay, and that's a recurring thing. You have to keep recharging your SMS account so that your service doesn't get disrupted. If you're using Amazon Cloud or Google Cloud, you're going to pay them. Prakash sir asked me a very pertinent question on day one, that what will it cost me to run one EC2 server? So that is going to be a monthly cost, 2,500 rupees, 6,000 rupees, something like that. So these are recurring service
Excuse.
costs.
Good afternoon, sir. Please repeat
Yes,
again, sir.
Prakash.
Yeah. Please
Yeah.
repeat again, sir.
So I was just giving examples, sir, that on day one you asked me how much should an EC2 cost. So that is kind of the cost that goes into the infrastructure cost. All right. You're going to pay that every month or every year. So it's a recurring cost for people.
Okay.
So
Okay.
that's why your name came up.
Okay. Thanks.
um, and lastly, you have support costs because there are going to be maintenance. It's hardware, right? Something is going to break down. There'll be replacements. There will be level one support and level two support teams that will go out to the site. Because see, IoT is not just sitting in a data center. IoT is out there in the field, in the real world, battling the elements and time and water and sunlight and dust every day. So support, maintenance, replacements, etc. And obviously you have to keep training your staff how to use these systems. So both of the above two blocks are one-time costs. Both of the lower two costs are recurring costs. So these are what goes into whatever is the monetary amount you pay to as a consumer to a technology provider. All right. And let's not talk about how much it should cost. Once again, there is no one magic number that car will cost you somewhere between 3 lakhs and 8 lakhs if it is not a Mercedes or a BMW. If you want a luxury segment, it will cost between 20 and 50 lakhs. There are no steady formulas for this, but what there are benchmarks, okay? And there are tools available online through which you can check what the benchmark is. So in the beginning, I told you that as a consumer, if I walk into a meeting thinking that it will cost me 10,000 and the service provider thinks it should cost 5 lakhs, then there is no meeting ground. So as a consumer, as an informed consumer, it is my job to make sure I get an idea of what is the ballpark cost. And it is very natural. It is a very obvious thing to do. When we go to buy a laptop, we'll do some Amazon search and find that okay, I should be willing to pay between 30 and 50,000 rupees. If I'm going to buy a plot of land, we'll see in that area of the country what is the per hectare or per acre or per foot. Thankfully, per square inch hasn't happened yet, but what is the per square foot rate of land in that place, etc., etc. So we are informed customers in all of those things, and we must extend the same logic into technology. So what you can do is I will show you a tool where we can, as consumers, we can go there and determine what kind of product I want built, and this is generally how much it will cost. All right. Once again, caveat, treat this as a guideline. We can't go to a provider and say, hey, the website told me it should cost 5 lakhs. This is a guideline into how these costs are computed. So let me show you a tool. We also use this tool sometimes to justify costs to ourselves before we make a quotation or an estimate for a customer. All right. So this is one of many such tools, but we like this particularly because it lets you choose what kind of IoT product you want to build. Before I start the demo of this tool, Rajshri ma'am, can you confirm that you can see this website? Can anybody confirm?
It's
Can you
visible,
see?
sir.
All right, perfect. Just wanted to see, ma'am, whether this website is visible.
Yes.
We can see it.
Perfect.
Yes, yes, it is visible.
So this is called Indima website. This is specifically built to help the IoT providers as well as IoT consumers to get a general idea of what an IoT small or large scale system would cost. Okay. So let's take any one. Let's take industrial IoT as one example. And if time is left, we will take one more example. So it's a very systematic tool. You can say I want an industrial IoT product. What all should this product contain? It should have customized hardware. It should have a mobile application. It should have a database. It should have a web also. I don't want a desktop application. I don't want a landing page. Let's calculate. So at the beginning, it will tell you that roughly, okay, these are the four things that cost. There's custom hardware, there's mobile, there's web, there is database. So let's go through them one by one and see what the cost will be. Okay, what is the device size? I want small devices. What is the environmental considerations? All these things I've shown you in the previous slide, and this tool takes them into consideration for calculating cost. I want a what moisture proof, but it's not going to be underwater, so I don't want waterproof things. Okay, I don't want too much accuracy. Plus 3% is fine. How many sensors per device? Let's say I want 5 sensors per device or 1 sensor per device. Okay, then you can say what all we want to do. We don't want user interaction. These are self-sustaining devices. We want data acquisition. We want, as I said yesterday, data ingestion. The physical world is going to feed data into your virtual system. Okay. What is the kind of connectivity? Once again, I showed you a slide. There could be a lot of things together. I want SMS communication and I want Wi-Fi communication. As a consumer, I will know this, or I should know this. All right. I don't want screens. My devices want to be simple. I want LED indicators. I want switchers, and that's all I want. I don't want anything more. How do I power my devices? Once again, so to be honest, when we built our deck, we hadn't seen this, but as you can see, everything ties back to their foundation thing. Remember, there is connectivity, there is power, and there is processing everywhere, because these are the things which determine what the IoT solution would be like, right? Now let's say I don't want a disposable battery, I want a rechargeable battery, and I want a wall power. Okay. Okay, great. Let's continue. Next step, what do I want my mobile application to be like? Do I want to see real-time data? Yes. Do I want a dashboard? No, dashboard I want on my laptop. Do I want it to support local language as well as international language? Maybe no, I just want it in English for now. How many sensors do I want to be visible on the mobile phone? I don't. Do I want Android or iOS? I want both. My customers are both Apple users and Android users. Are you building it as a platform to sell to other people, or are you building it for a specific client? I am building it for a specific client. Okay. Why that matters is because if it's a platform, the cloud capacity required is going to be even more. It will cost you more. Is there a login? No, there is no specific login required, just a regular thing. Components, what all do you want on the mobile app? Let's say I don't want any of these. Okay. Then I can say next. Okay, so it forces me to select. I want device management, let's see, and I want just username, password, login. Okay, I can say continue. Now, what do I want on the web application? Should it work on all devices, including mobile phones? Yes. Does it show real-time data? Yes. Does it have a dashboard? Yes. Is it multilingual? No. For clients, others authentication, what all am I using? Here I want maps and I want device management. All right. And then let's talk about database. Big data analytics, no. Real-time data, yes, because we are ingesting data. Okay. AI be used? I don't want AI. How many users I expect? I expect to have about 1,000 users. And on the database, I don't want any of it. I just want, say, device management. Device management means can I switch my devices on and off, configure them remotely, etc. And then this gives me a ballpark. So this is from a customized product point of view. So this will tell me to just develop a prototype, what I've said, something like this, or just a trial version of the device. The minimum cost would be somewhere about these many dollars, and the maximum would be this. All right. To take it to a prototype or a proof of concept or an MVP, something that we can show to the customers, the cost will increase because you're bringing in a lot of testing, etc., etc. Minimum this, maximum this, and finally to bring it into the market, to market it, to talk to sales groups, etc., etc. You increase your to comply with regulations, emission standards, waterproofing, etc. How much it will cost. So as I said, take it as a guideline. This is probably from the US market. European market will be something else. Even in the European market, if you go to Poland and Romania, the cost will be different. Costs in India will be different. But what you can use is the ballpark. Let's say for India, technology costs are one third, which is actually true. In India, if in the US market, if the cost of something is $100 technology wise, in India it's going to cost you $35. All right, so you can simply one third that cost. But one thing this chart gives you, which is very useful across all geographies, which is not going to change, is how much time is it going to take, the hours column. Okay, this doesn't matter whether the technology team is an American team or a European team or an Indian team. It doesn't matter. This is roughly gonna remain the same. Okay, so looking at this, we have a fairly ballpark idea in the plus minus 50% range that this is what it's gonna cost me. All right. That's why we really like these tools. There are other tools as well. Every tool will give you a little different number. But if you use as a consumer, if you look at this tool, just like we look at, internet website, that what is the cost of land, what is the cost of hardware before you go there. If you look at this, there are no surprises when you go into negotiation with the service provider. All right. So excellent tool. We recommend it to everybody. With this, let me go back to my deck. Yeah, and then comes the question of, whether we should get a custom product built for us or whether we should go for a ready-made product, all right, on the shelf. And both kinds exist. It's as good as saying, if you want a messenger, should I go and buy something like WhatsApp, or should I invest in one of my own technology providers to build something like WhatsApp for me? It's called a build or buy decision, all right. So there are many benefits of both. We are primarily, I think IoT is in a stage where there are so many different use cases. It's very difficult to build ready-made products. Some of these things exist because these do just one thing. They just switch on and off and light. But if you're looking at all the other use cases I've shown, it's largely a customer requirements driven market. And there are pros to it and there are cons to it. So I'll quickly walk you through them. And after that, we will do a very quick case study of when a customer was well informed and how it worked for them, and when a customer was not well informed and how did that backfire. All right. So if you look at the pros of custom driven software, the biggest plus is that it will have everything you need and nothing that you don't need. So it's like I'm just buying a phone because I want to call people and I want to check internet couple of times a day. I don't need the camera, I don't need the voice commands, I don't need so many other things happening. I don't need a micro SD, but you can't help it because it's a product. If somebody made a custom made phone for you, it'll have every single thing you want and nothing that you don't want. It's tailor made for you. All right, that's the biggest benefit. Because of that, the second benefit is you have complete control over this, the scale, what all goes into it, how long does it take, what do you want first, prioritization. I want the motor first, and the liters of water monitoring can come later, for example, right? Third example is you can plan for the future. Today, as I said, phased development, like the government projects I told you about. Uh, you know, Today I want these 4 features. Next year, my company wants something more, so I can plan it in right now. This is my product that somebody else is building for me. Okay. And the fourth one, it's a competitive edge with hardly any licensing costs. Okay. And typically you will continue to have complete ownership over the product. There are caveats. For example, what we follow in Copper Cloud is we don't give complete ownership of the product. We charge the consumers less and we retain the intellectual property rights because we want to be able to sell the same product to a different consumer. So it works for us and it lowers the cost for the consumer. Okay, so this is kind of debatable, but largely you can ask the provider that I will pay you more, but this you will not sell to anybody else. Okay, so you get that kind of control with a custom product. Now what are the cons of a product? Obviously you have, the thing will take time to build. Somebody is building it for you, so it's not going to be instantly available. So a couple of months ago we had a very urgent requirement and we spent about 3 days talking about the requirement, and on the third day the consumer told us, but I want all of it in 6 weeks. If you can't give it in 6 weeks, then it doesn't work for me. And then we said you should have said this on the day one, because a custom product will take 6 months to build, maybe 6 weeks. You're looking for a ready-made product, boss. And we pointed them to other suppliers which already had some similar products. So nothing is immediate. It needs time to build it. You have to water the plant and you can eat the fruit after 1 year. If you want a ready-made fruit, you go to an orchard and buy the fruit from them, things like that. Okay. The second one is it is requires more effort and time from the consumer, because I'm just in the previous Madhu's session we saw that agile ways customer needs to sit with us every week and see, yes, this is what I like, this is what I don't like, build it this way, change it this way. So it requires a more time commitment from us as a consumer. All right. It could be a larger financial investment because the people building it are not building it as a product that I sell thousands of these. They will build only once for you. Once again, that's a little debatable because the way Copper Cloud works, we do it differently. We make sure that the consumer pay less, even though it's a custom made product. Okay, but depends on different providers. You cannot fully see the product before it is made. Okay, obviously, because it's not yet built, you are helping build the thing. And finally, there is no existing user community. Most often you can say, if you're buying a laptop, you can say, hey, should I buy a Dell? Should I buy a Sony? Should I buy a Acer? And people have bought this thing in the past, so they can tell you what is good and what's not good. This has never been built before, so you can't go to existing user community. That's the last con of the thing. Okay, largely it remains a custom based market because everybody seems to have a unique requirement. All right, so but that's what it is about. As a consumer, we should know what we are gaining and what we are losing between a custom and a ready-made product. All right, with that I think we have already hit 315, sorry, 115, but I will request just 3-4 more minutes to go over a case study where we will cover all this stuff. All right. So I'll give you two examples. In one case, they're very similar consumers. Both of them were in the they owned manufacturing plants for creating automotive parts, different kinds of parts which are used in the automotive industry. Okay, one of them in Pune, the other one in Indore. And these are real, I'm telling you, real use cases. So there's a big difference in the approach that these two parties had. Both their journeys started in exactly the same place, and both of them had a really good vision that I don't want my people, running around taking notes. I want to remove the user intervention, and I want all this data. As I showed you the first slide on industrial automation, I want all this data. I want the machine to send to my database, and I will sit at home and I want to look at the dashboard. That's what I want. One of them had 20 machines, one of them had 50 machines. Now, this is where the paths diverge. That I'll first tell you the happy part where we had a very well informed client. Now they did not know about the technology, but they knew what questions to ask. First off, I told you the first meeting they says, I like this product, but my fiber optic cable is not reliable. How can you make sure that I don't lose data? And then we said, okay, let's solve that problem using a Raspberry Pi. And then they says, I have got three-phase power, and there's someplace else I have a single phase power. How are you going to deal with that? Things like that. Most importantly, right, they went over every single piece of functionality with us. They did not presuppose anything. They knew of PLCs, they knew of FPGAs, they did not know about Raspberry Pis and microcontrollers. So they asked us the questions. What will it cost me? and why will it cost me so much? Okay, I have 3 factories here. I don't want a different dashboard for each. How will you give me? So this what, when, why, how, and how much are very important questions with these kind of informed decisions. Okay, and ultimately we are now building in from a 50 machine shop, and this is a party which was very clear in what they wanted. They were a third level supplier to large makers like Maruti. So they sold their parts to somebody, that somebody sold it to somebody else, and that somebody else sold the components to Maruti. And our clients want to become the first level supplier to Maruti. And Maruti says, sure, let me come and inspect your plant. And when they come, they have a long checklist, how much automation you have. And there's a good reason for that. What Maruti says is, when one of your machine breaks down, one of my cars in my Gurgaon plant stops being manufactured. So we need a dashboard in the Maruti headquarters in what is the state of health of your machines in Pune. Okay, and that's why they are not able to crack that wall. And with all this automation, they right now they are scoring 20 out of 100 on Maruti's checklist, and we have assured them they want us to make them score 80 out of 100 on Maruti's checklist, and they are very clear with what they want, and they're willing to invest in this, right? And that project is already well underway. So this is the happy story of a really well informed consumers who doesn't know technology, but they know all the right questions to ask. They know how to get to the right people to build it to them, and they know what they want as an end result. Okay, now the other story starts very similar way, that we have a very enthusiastic client who wants automation, who wants technology, but they have a lot of preconceived notions. For example, in their minds, factory automation means PLC. PLC means I will be spending 20 lakhs on this. So there itself, the train starts going off the rail, because this is not a well-informed consumer. All right. It takes a long time to even tell them that the PLC is not the only choice you have. All right. At the same time, some PLC vendor comes and says, I will do it for you for 50,000, whereas that's just not possible. An informed consumer would know that a single PLC solution would cost you 1 to 1.5 lakh. So there is no way that somebody can do it for 50,000. All right. And finally, what happens is, after 1 year of doing a prototype and having these discussions and everything, their shop is still not automated. All right. Whereas the other consumers started about the same time, and now they are already on the third factory doing it. So see, it's not just about the client, not giving us that work. It's a lose-lose. The client also loses an opportunity to do something good and come into the fold of industry 4, right? It's also a lost opportunity for the providers, and net it's a loss for everybody. On the other hand, if the providers are informed and if the consumers are informed, you can get to a deal quite quickly and build and start doing something productive with this technology. Technology sitting on the shelf in the lab is no use to anybody. Technology which is deployed in the real world does magic for us. All right. So I thought it'll be a really good idea to share these case studies. On the final note, as technology consumers, we have to remember that our tech providers are our consultants. All right. And the consultants will help us fulfill our needs. And as tech providers, let us remember that our job is not just to build the solutions to the people who are paying us. Our job is to guide the consumer make informed decisions. Sometimes the informed decisions may not be in our best interest. For example, somebody who says that I want this in 6 weeks, we could have said, yeah, sure, we'll make it. And we start making it and we get them stuck for 6 months. That is not guiding the consumer. We might have to say, go to our competitors, they have a ready-made product, but our job is to guide the best interests of the consumers. All right. And that is called a win-win. That's how we get to what both parties want at the end. All right. So I hope everybody liked this session. It was a very different session. We dived into what a consumer is thinking, and we stopped thinking like engineers for 90 minutes. And thanks for complying with my request. Uh, I haven't seen these sessions anywhere else, so I do hope that it was enjoyable and it was a little bit eye-opening for everybody. So I'll take questions now.
Yeah, thank you, Abhijit, for this very different session. So I request the participants to ask any questions they have.
Good afternoon, sir.
Yeah, yes.
Uh, Sir, as you have explained, there is a Calc Indina, the estimation tool, which is available for the projects of type that comes under the IoT. Could you please suggest a tool which is more common for every type of software?
Yeah, so that's a good question, Rijwan sir. The thing is, we try to look for one, but what is happening is each of these technologies has followed such a different model that I found a separate tool for just websites. I found a separate tool for data solutions. It's very difficult to build everything in a single tool. I understand your question that the same technology might want websites, might want 5G, might want apps, might want IoT and AI. So what we do in those cases, we break down the cost into these different components. I haven't found any tool which is reliable, which gives you cost, and I think this is the way it should be. This is better reflective of the differences between these technologies. But I will share you the different links for the major technology costings.
Well, that will be helpful, sir. Thank you.
Sure.
Yeah, how does the complexity take into account for price tagging? Here's one question from Mr. Vijesh.
Yeah. So let me go back to that tool. I think the question is how does this calculator take into account complexity? So let me go back here and show you how. And this is actually a very brilliant question because this reflects how the industry is changing. All right. Way back 10 years ago, 15 years ago, we would factor in the complexity of the product in terms of, how do you price it. Today, we don't look at the technical complexity when we are coming up with a price. We take into account complexity when we come up with a cost. How much do I have to pay my developers? I have to pay Apple developers more than I pay Android developers. I have to pay data scientists even more, and architects, we have to pay the top dollar. That's all cost. Consumer doesn't care about the complexity. Consumer cares about what functionality I am consuming. All right. And the entire pricing model has changed. It is now called function point based pricing. It is not a technology based pricing. It is not a complexity based pricing. It's a functionality based pricing. What I am delivering to the consumer. All right. Which is why in this calculator, you will see that you're asking lots of questions which are pertinent to the consumer. Now let us say, let's go down below and let's say I want a cellular, I want a Wi-Fi, I also want LoRaWAN. All right. Now this is pretty complex, but to the consumer it doesn't matter how the provider is managing complexity. They are going to look at I want these three functionalities to work together. So from a pricing point of view, technical complexity has ceased to be a factor. It is a factor in cost of the product that I will pay to my company, to my team to build it. I will not factor it in when I decide pricing. I will decide how much value am I delivering to the consumer. That's what the industry is doing these days.
Abhijit,
Yes, sir.
uh, do we get ready-made apps for connectivity to the Node MCU?
We do, sir. We do get it, but we still have to write the code for Node MCU. All right. And there are two ways we can talk to the Node MCU using these apps. One of them is your Node MCU can become the Wi-Fi hotspot, and your app just talks to it and returns back to your app. It is good when you're talking to just one Node MCU because then you have to keep switching. If you have to talk to the second Node MCU, you have to switch off that connection and start a new one. The better way is for Node MCU and all the 5, 6 Node MCUs to connect to a central hotspot. For that, I think I don't see a ready-made app really, but I showed you everybody an app yesterday, home automation app. You can drag and drop and create a UI and it will be codeless where you can talk to multiple node MCUs at the same time.
Okay. So if somebody is requiring the app for controlling the node MCU, so do you charge for that also? The product cost include the app or it is excluding the app?
Yeah, it will, because it's a piece of functionality. So let's say I'm giving three things to the consumer. Let's say they want to automate a light, a fan, and a security sensor on their door, and they want a mobile phone to activate the sensor only after midnight, things like that. Okay, so yes, there are three distinct pieces of functionality that the consumer is using. They're using three sensors and one mobile app. Now they don't care about what cloud you have it on or whether you have it on MQTT or MySQL or not. But these four things they are consuming. So yes, your pricing model will reflect all of this. Unless you have a model like Ola or Uber that you are making money on a recurring basis. The app is a means for your business, your company to make money. It's not just a product. In that case, you want more and more people to use your app, in which case you will make it free. But if it's a custom product and you have built that app for a specific customer, then you will charge for it.
Okay, thank you.
Sure. And I must say, I'm very happy with the questions we are getting. I'm almost getting the kind of questions that we get from our clients. So this tells us that our faculty community is very up to speed on, as I said, it's a very informed group in terms of the right questions to ask. Any more questions on this part, the consumer part of things? Right. I think we are out of questions, Dr. Patil sir.
Yes, yes.
If you like,
Okay.
we can reconvene.
Thank you very much, Abhijit. So we'll meet at 2:15 again after the break. I have already shared the link for session number 3 on mail, and we'll share it on WhatsApp also. Thank you.
Sure. Thanks, everyone. We'll meet again at 2:15.